Okay, so for tonight, we're in the land of trigonometry. And in the previous lesson, we spent quite a bit of time talking about reduction formula, which are these types of formulas. We also have to be aware of using reduction formula with co-ratios. Okay, so that was a lot of the last lesson. We also spoke about special triangles where we can evaluate trig expressions without a calculator. Now, what we didn't touch on were additional trig identities, like the quotient identity, which is written like that. And then what we call the square identity, which is sine squared theta plus cos squared theta is 1. And what's more, this can be rewritten in other forms. If I move the cos to the other side, I get sine squared by itself. And if I move the sine squared to the other side, I can get cos squared by itself, cos squared theta. Give me a thumbs up if you are familiar with all the content on the screen. Give me a thumbs down if you are not familiar with all the content on the screen. Because the basis of this lesson will be around this content. So we best iron out any spots at the beginning. Okie dokie, then let us go and do this. So let us do, this is sort of following on from the last lesson, but let's do this question over here. I want us to try and simplify without using a calculator, number 3. And what you're going to need to do is you're going to need to reduce each of these pieces in whatever way you think is helpful, and then go from there. So I'm going to give you a minute or 2 minutes to do those reductions, and then I'm going to ask for questions as you go. All right, over to you guys. Let's see what we remember and can extend from the last lesson. How would we handle tan of 480? Visually, I need to go all the way around the circle and then go a bit more. I actually need to go 120 more. So I'd be in that quadrant. So careful, it's actually not what's the nearest horizontal. The nearest horizontal is actually 540. Like if you think about going 0, 90, 180, 270, 360, 450, 540. So if I really wanted to be technical, I would go 540 minus 60. Now, there are other ways to do it. You could also write it as 360 plus 120 and then reduce the 120. That's also fine. But just to follow kind of the idea of the nearest horizontal, I've done that. And that's going to reduce to, eventually, that's in quadrant 2. So it's going to end up being minus tan 60. So as long as you get to minus tan 60 for that bit, you're fine. But yeah, there are different ways of doing this. Where did I get the 540 from? So for Techo, I was trying to identify the nearest horizontal axis to 480. And if you look at my little drawing at the top here, right, 0, 90, 180, 270, 360, 450, 540. 540 is actually the nearest horizontal. So I'm using the nearest horizontal to write the original angle. There are other ways of doing it. It's not to say you have to do it like that, but that's keeping with what I was saying in the last lesson. And then the other thing is a negative angle. That's going to cause a few headaches. Where is the nearest horizontal to minus 135? So if that's minus 135, what's the nearest horizontal axis to minus 135? Well, if I go in the negative direction, I think the nearest horizontal is minus 180. So this is a little bit more of a tricky one that I'm getting you to start with. So what do you think I'm going to write in this bracket here? I'll give you some time. Would you get to the same answer? Because you need to get to minus 135. I was thinking, why don't I go minus 180 is the nearest horizontal? Why don't I just go minus 180 plus 45? Does that get me minus 135? Yes, it does. Is it using the nearest horizontal? Yes, it is. So that it's not to say you have to do it like that, but I think that makes sense. And then for this one on the bottom, the sine of 104, you don't have to, but I was thinking I could write it as the sine of 90 plus 14. And then for the cos of 225, I was thinking I could write that as 180 plus 45. Now I still have to do my reductions, but give me a thumbs up if you follow. I know the most difficult ones here are that one and that one. And there are other ways of doing it. But think about what's the nearest horizontal axis? It's 540 in the first case, and it's minus 180 over there. Okay, so I know that is a bit tricky. So just hang in there for now and ask yourself, what do you think these other ones are going to convert to? So what's the sine of 360 minus 60 going to be? That's in quadrant 4, so it's going to become minus sine 60. The cos of 14 is going to stay the same. What is going to happen to this thing? What is the sine of minus 180 plus 45 going to reduce to? So it's going to become, what quadrant is that in? It's in quadrant there, and sine is negative, so it's minus sine 45, yes. Don't worry, I see everyone's struggling a little bit, so we'll go back and do number 2 as well, which is also a good question for this. Now, there's something different about this one. What is different about the green one compared to all the other expressions I've written? What is different? It's a co-ratio. So when I reduce this, I need to remember I'm in quadrant 2, sine is positive, so that's fine. But now this is going to become the cos of 14. And then this one is in quadrant 3, so it becomes minus cos 45. Okay, what's my next step now? What's my next step now? Who feels like they can contribute something? I definitely notice that this and this are the same. So that can go away. I also notice there are 2 sets of negatives, which give us a positive. And then another 2 negatives here. And so those become a positive. So after all of that, let's see if it's a little bit less cluttered. I've got the tan of 60 times the sine of 60 times the sine of 45 over the cos of 45. Okay, now I need to make, now we already, most of the marks in the bag, but I need to still make some choices. It says simplify without a calculator. What's next? I feel like these two are somehow connected somehow. You could go to special triangles, you're right. So you could just go straight to your special triangles now. So what are the special triangles? Let's try and remember them. They have 45, 45, and they have 60 and 30. And this has 1 root 2. And this has 1 root 3, 2. So what you could do at this stage is just say, look, I need to fill out all these brackets over here. And if I fill them out, I'm done. Okay, I just use those triangles. The one sneaky thing you could do is the cos of 45 can actually be written as the sine of 90 minus 45. And then what can you reduce the cos of 45 to? What can the cos of 45 be rewritten as? I'll give you a moment to think about that. What can we reduce the cos of 45 to? I think it can be written as the sine of 45. Yes. And that's awesome because now I cancel that out. So I'm left with the tan of 60 times the sine of 60, which, using my special triangles, the tan of 60, so is going to be O over A times O over H, as long as my O's are in the right place. So O, H, A. So O is root 3 over 1, and O over H is root 3 over 2. So now you get 3 over 2 as my final answer. Yo. Quite a bit of work there. Are there any questions or comments? So how can you explain how cos 45 became sine 45? I absolutely can. So sine of 45, sorry, the cos of 45, this is what we call a co-ratio. The cos of 45 can be written as the cos of 90 minus 45. And that's using the nearest vertical axis. Okay. Now, the nearest vertical axis is fine. But if we use the nearest vertical axis, we then have to change, or first of all, is this positive or negative? It's in quadrant 1, so it's positive. If we use the vertical axis, we need to use the co-ratio of cos, which is sine. And how far away is it from that axis? It's just 45 away. And that's what we call reducing using a co-ratio. Okay. I feel like we need another question like this to help us. And so what I'm going to do is I'm going to ask you to do question 2, which is very similar. So let me go and grab that. And you can start on that. So I'll leave this up for a little bit while students are kind of thinking and for any other questions. But for everyone else, I want you to try and simplify number 2. Josh, it's not wrong to go 480 minus 360. All that's going to give you is 120. And then 120, if you reduce that, will give you your minus tan 60. So you get to the same place. So completely fine. Okay, see if you can do number 2. So Melo has asked, when do we know to use the vertical and when to use the horizontal? So most of the time, let's say 80% of the time, you're going to use the horizontal. And the reason you use the horizontal is it's simpler and you want to keep life simple. But sometimes you need to know how to use the vertical axis when you need to switch from a sine to a cos or a cos to a sine, or the question forces you. And you'll see some questions like that now, but essentially you need to have both tools in your toolkit, but most of the time you're going to use horizontal. In some situations, you could choose either, and as long as you do it properly, it won't make a difference. Like you can use either, but I would recommend using the horizontal most of the time. It's just less likely to make a silly mistake. Okay, I'm going to clean my board. So if you need to take a screenshot, take it now, but otherwise I'm making the stuff disappear. So we're doing number 2 now. Here we got that. I've written the ones in red that are already in the form of the nearest horizontal axis. 360 is a horizontal axis. You don't need to do extra work there. But in the other cases ones, like this one, I used 720 because for me, that was the nearest horizontal axis. Here I used 0 because that made sense for the negative angle. And here I used 360 and here I used 360. So you still have to now reduce these in the next step. And this would get quadrant 1. So this should be cos 30. Keep those questions coming in the chat if you're confused for some reason. These are tough questions. I suspect students are going to be wondering about this one. But remember that this is in quadrant 4 and cos is always positive in quadrant 4. And so if you imagine a negative angle, right? Here's negative theta. Negative theta goes in that direction. But it's still only theta away from 0 degrees. So that's why I wrote it as 0 minus theta. In this quadrant, cos is in fact positive. So that's why it's plus cos theta. So for Tekel, what you need to ask yourself is cos positive in this quadrant? And it is in fact positive because it's in quadrant number 4 from the cast diagram. Lumelo, there are other ways of writing it. You don't have to write it exactly like I write it, but you should end up getting the same answer as me. So that's the main thing. There are many ways to write these. I don't want to obsess about that, but what I do see is that both of us have a cos theta on the top and bottom, in which case we can cancel out that. Now, what should be my next move? Any ideas for my next move? I see two negatives, so that can cancel out. So yeah, I think now we go to special triangle, or if you spot a little something, there is, I see what you mean. The sign of 60 can be rewritten in another way, can't it? So this can't really change. This tan 45 needs to be what it is, but this cos of 30, so that's fine. The sine of 60 can actually be written as the cos of 30. And so that would cancel out. And that's a little bit quicker because now I only need to use the one special triangle. So I'm going to have the sine of theta on the bottom. And what am I going to have here? What is the sine of 40? Sorry, tan of 45. It's 1 over 1, which is 1. So my final answer is just going to be 1 over sine theta. Thumbs up if you are feeling okay. Thumbs down if you're not feeling so okay. Thumbs down now. Okay, let's do another one because we don't want you to feel like you're not, sometimes when you go to the gym and you're doing a whole day, but I want everyone, before our break, I want us to do one more, and that is going to be question 4. Let's do question 4 and see how we go on that. Each time we do this, it just gets a little bit easier. So let's do question 4, and then we're going to take a break.
Oh, so
yes. Hi, Nompilo.
Hi, sir. So I would like to ask a question.
Okay.
So you see by the cos 720 plus 30.
Yes.
So I don't understand how you got cos 30 at the end.
Okay. It's got to do with the idea of the horizontal axis. So if you imagine that I go around once, I go 90, 180, 270, 360. Then if I keep going, I get to 450, 540, 630, and 720. So I have 2 lots of 360. Now, if I want to go a little bit further, I get all the way up to 750, which is what I had in the question. So this little bit here is just 30. So that's how I got the 720 plus 30. Does that make sense?
Yes, sir. Thank you very much, sir.
Pleasure. Thanks for the question. Okay, so let's clean the board for this next one. Okay. There's a couple of different ways you can do number 4. So it's not to say that it's, you have to do it the way I do it now, but let's see. feels like that would be my first round. And the vertical axes are the ones in yellow, and then the horizontal axes are the ones in green. And so I must remember I use different rules depending on what axes I use to reduce. Let me know in the chat what you think you get for your final answer, or if you've got a question about a step. It is okay. So Lomelo has asked, can I use the horizontal for everything? You can. So instead of writing 270 minus 10, what you could do is write, what's that going to be? 180 plus 80. Yeah, and that's completely fine. In some ways, I suppose that's probably even better because it's less likely to be, but both ways will end up giving you the same answer. So let's see what happens if I do this. I get quadrant 3, so minus. So could we also say 360 minus 100? You could, but then you're still going to have to reduce the 100. So Bokanyo, there's no problem. You're absolutely correct. But remember, when you get the 100, you're going to have to reduce that again. So you'll still get the right answer as long as you don't make a silly mistake. But yeah, okay. Let's see what else I can do here. I think a cos 10 and a cos 10 can go away. And I also think a negative over a negative is a positive. So I'm now left with minus cos 80 over the sine of 10 times the sine of 10. Ooh, that's looking a bit messy. What should I do next? Yes, so it would make a lot of sense to change the cos of 80 to the sine of 10. And because you're in the first quadrant, okay, the minus is already there, but this just becomes the sine of 10. And then you have the sine of 10 times the sine of 10. That cancels, and you left minus 1 over the sine of 10 as your final answer. Yeah, so remember that the minus was still there. How did you get the cos of 80? So if you think of the cos of 260, the cos of 260 can be written as 180 plus 80. So 180 plus 80 is 260. And then you say in quadrant 3, so quadrant 3, cos is negative. So that's why I've got this negative. And how far is it from the nearest horizontal? It's 80. So that's why that is there. Does that help, Caitlin? Okay, the question has been asked, how did minus cos 80 become minus sine 10? Okay, so let's have a quick look and see if there's any little silly mistakes here. So this thing is in quadrant 3, it has to be negative. This is in quadrant 2, and cos has to be negative in quadrant 2. So that's why I've got the negative there. Sine of 10 stays the same. This is in quadrant 3, so that's why that negative comes from. And this cos of 360 minus 10, it's in quadrant 4. That's why it is positive, but I just left it out, but it has to be positive. If you look at how many negatives there are, 2 of the negatives will cancel each other out, and you'll get left with a negative over here. cos of 80 was already there. That was already there. Now, if you change, you can change the cos of 80 to the sine of 10. That is reduced. I have skipped a step there in terms of writing it like cos of 90 minus 10. But that's the process you're going to follow. The negative is still out in front. Now you cancel one of the sets of sine 10, and you're just left with the same minus, and then the sine of 10 on the bottom here is still here. All right, we have worked. Would it still be correct if you change the sine 10 to cos 80? Yes, it would be. Naledi, it would be completely fine. In fact, it would be just as correct. Okay, it's time for a break. So I'm going to ask you to stand up with me. We have been working very hard, and it's almost like we need our brains to click save as, because your brain will remember this. But if you put it under too much pressure, it's almost like it just throws it out. So I really do want to encourage you, take a moment to stand up. If you're feeling stressed about something, don't worry, we're not running away, but you need to take a moment just to breathe and to get your blood pumping. Okay, so let's start with some breathing. So in. One more breath. Okay, so release some oxygen into your body, then just shake out your arms so you get some circulation. Shake out your legs. And let's just do a little bit of a rotation from your hips. Just a gentle rotation. And then as you are starting to relax, you'll feel your body will turn a bit further, which is a good sign. It means you're relaxing. Shake out those arms again. Shake out those legs. And you know what's coming next. I'm going to get the blood pumping, and we're going to do jumping jacks. So make sure the space around you is clear. You're not going to whack anybody or anything. And we'll do 20. And we're going to start in 3, 2, 1. Let's go. 2, 3, 4, 6, 7, 10. Halfway. 15, 16. One more. And ooh, my heart is now pumping. I hope yours is too. And we are running a bit short on time, so apologies to all our big Maths 24 fans, but I am going to move on to the next type of question I want to show you guys. Okay, so we're going to move on to proving identity questions. And here is an example of some sort of exam type questions. And the way these work is you have to basically choose one side to work with. Normally you choose the harder side to work with, and then you try and make it equivalent to the other side. So of these two sides, we'll say this side is the left-hand side, and this side is the right-hand side. Which one looks more tricky to you? Let me know in the chat. Somehow lost the... Can you still see my screen? Let me just reshare. Sorry, guys. There's the chat. Yeah. Okay, cool. Yeah, so it looks to me like the left-hand side is the more tricky one. So what I'm going to do is I'm going to write left-hand side. That tells my marker that I'm working with the left-hand side. So that is going to be sine of x times the tan of x plus the cos of x. And my goal is to work with this left-hand side and make it equivalent to the right-hand side. Now we only have one choice really here. What's the one thing I can change in the left-hand side that maybe can help me get to what we call the promised land here, 1 over cos x? Any suggestions? Yeah, so the only thing I can see is that tan of x can be changed to sine of x over cos of x. And there was already a cos x over there. So that's a good start. But it doesn't really get me there yet. So now, what would my next step be? Any ideas? It was really the only thing I could do, but I'm still a bit stuck. Denominator. Yes. Well, I was thinking if I multiply these two together, I get that. So at least it looks a bit neater. And now I have to add these two together. Okay, this is going back to sort of grade 9 a little bit. If I want to add two fractions together, although actually to make sure that that's a fraction, I'm going to put it over 1. What do I need to do to add two fractions together? I need to ensure they have the same common denominator. So what is that common denominator going to have to be? Yeah, it has to be cos x. So the way I sometimes like to show my students is I say, look, I'm just timesing the bottom and the top by the same thing. And anything over itself is 1. And so now this can be written as that over cos x, because that cos x was the common denominator that I created. All right, at least I'm getting warmer. Now, seeing all those squares makes me a bit excited. Why does it make me a little bit excited that I see all those squares? Because that's called the square identity. And so sine squared x plus cos squared x is just going to be 1. And so now I have 1 over cos x, and that is exactly what the right-hand side is. And so I have completed my proving the following identity. Give me a thumbs up if you followed that logic. Give me a thumbs down if you felt a bit like, whoa, 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 what's going on there? Okay, now they can get harder than that. And so I need to show you a couple of tricks of the trade before we go and approach any harder ones. So a very common technique that is used in these questions is writing, if you have to add two things together. Okay, so these are a couple of useful techniques that I want you to keep in mind as we approach these questions. So if I have something like cos x over sine x plus sine x, and you have to add them together, a very common technique is to know, put that over 1, and then say, I want to create a denominator that's the same, but I can't make stuff up. So what I do is I multiply the top and bottom by the same thing. Then, let's pretend this was a cos squared to start with. Then, if I now do this, I get that. Okay. And so what I've done is I've artificially created a common denominator. And now what I can do is, if my denominators are the same, I write down my denominator. Now I'm just making this up here to show you this technique. What is cos squared x plus sine squared x the same as? It's the same as 1. And so this whole thing will be 1 over sine x. So I really want to point your attention to the first trick being put it over 1, the second trick being multiplying the top and bottom by the same thing to create a denominator. That's the first little technique that I want to make you aware of. The other techniques that I want to make you aware of are multiplying. Let me actually choose something like, so sometimes you will see that we have like 2 over 1 plus cos x, and maybe I have, let's say I have 1 plus 1 minus x. Okay, let's say I have this. It looks like a bit of a mouthful. Sometimes what you can do is, if you have a situation like this, you don't multiply, you've got a fraction by itself. If I multiply the bottom by 1 minus cos x and the top times 1 minus cos x, have I changed the original fraction? Yes or no? So this is my original fraction. I times the top and bottom by 1 minus cos x. Have I changed anything? Yes or no? Well, if you multiply something by, I changed something, but this is really equivalent. This whole thing is 1. And so the original expression is actually still the same thing. It's just that it's going to look slightly different, but the value is still going to be the same because it's just multiplying by 1. Now, if I had to do that, what is useful to think about is, on the top, I would get cos squared x times 1 minus cos x. Now, that's a little bit of a handful, but no worries. But on the bottom, can you see that this is a difference of 2 squares? 1 plus cos x, 1 minus cos x. What is that going to condense down to if that's a difference of 2 squares? So if you've got 1 cos x, imagine it like this. You have 1 plus cos x times 1 minus cos x. What is that going to be equivalent to? Doesn't a difference of 2 squares just have the first square, which is 1, minus cos squared x? And then what? Okay, let me just stop at that point and make sure you guys followed that, because that was a bit of a handful. So when I multiply these two together, I actually get what's called the difference of 2 squares, and I get that. I want you to think about, what is 1 minus cos squared x the same as? If you go back to earlier in the lesson. So 1 minus cos squared x is the same as sine squared x. Yeah. Now, the top is going to stay the same because I just made this question up. But I just want you to remember the technique of forcing a difference of 2 squares, because it can be helpful. Now, I want to see if I can do one of these harder questions with you tonight. So let me clean my board. And while I am cleaning, I want everyone to look at number 2. So I want you to think about, how would you approach number 2? Give it a go, and I will come and give you some tips in a little bit of time. But first, I want you to think about what How would you approach this question? And I'm not even sure if the techniques I've showed you now are involved. I wanted to show you those techniques just in case. They do come up in harder questions, harder identity questions. Let's make this a bit bigger. I think that's going to be the harder side. So I would work with that side first. Okay, what would your first step be? Who would like to come on and tell me, or tell me in the chat, what should I do to start the party rolling here? What would you do? Just give me an action. A bongwe? Let's unmute a bongwe.
Hi, sir.
Hey.
So I'd take the tan x and make it sin x over cos x.
I think that's a good idea. So let's do that. And this part over here is going to kind of stay the same for now. What would your next step be?
Taking the sin x and the sin x and making it sin tx over the cos x.
Yeah, so it's almost like that trick that I was talking about earlier on, where like you multiply this by cos x and cos x.
Yeah.
I like that. So we get sin x times cos x over cos x plus sin x over cos x. Now this is a sneaky one, not sneaky, this is a hard one, but and then this stuff is still just hanging out over here. Then so that's that whole thing. Who has an idea for what's next? I've got all the way down here. What am I going to do next? I don't feel like I can do anything to this at the moment, or this. It feels like all the action is over here. What techniques do I have in my toolkit to help me here? Any ideas? I'll give you a small hint. Yes, Kapotso, you have spotted it. There is a common factor of sin x, and if you take it out, you should get cos x plus 1. Now that is a good sign. And over here, you have cos x. And then over here, you have sin x over 1 plus cos x. Who can spot something here? Who can spot something important? I think cos x plus 1 feels very similar to 1 plus cos x. Is it the same? I think it is. So we can cancel out those two. Yes. Now, the good thing is it's simplifying a lot, but I need to keep track of where I'm actually heading to. So if I look at what I'm trying to get, I'm trying to get sine x times tan x. At the moment, all I've got is I've got sine x times sine x over cos x. What do I need to do? It's almost there. I've got a sine x and a sine x, but I need a tan x. And what you'll notice is that, in fact, this becomes tan x because sine x over cos x is tan x, which is then equal to the right-hand side. There'll only be one identity question. And what I would encourage you to do is look over some past papers and see the different techniques that are used. But this gives you a taste of kind of what an identity question can look like. You normally work from the harder side to make it look like the easier side. And you use a couple of different techniques like I've showed in these two examples.